Welcome to Lesson 4, Video 1 for the Intermolecular Forces unit in Chemistry 2. This is the last page of our note packet, and we're going to take a look at phase diagrams. So our previous lesson dealt with heating curves, and it showed energy added and temperature. This one's going to show the interplay of temperature and pressure. And phase diagrams look similar for all substances. It shows how temperature and pressure, the interplay of those two, give us our different phases. So we have different segments and lines in here and different regions. So something that is under relatively high pressure and low temperature, so this region up here is going to be labeled a solid. The region down here where we have low pressure and it can increase and we can go up high in temperature, this represents a gas, and that leaves us with liquid right here in the middle. So if we look at these different areas, segment AB, so this line segment right here between a solid and a gas is called the sublimation curve. So we can cross this line by increasing or decreasing pressure, or if we hold pressure constant, we could increase or decrease the temperature. So depending on where we start and where we end up, we have our different phase changes. So if we're going from solid to a gas, we have sublimation happening. And if we go from here, a gas up to a solid, we have deposition occurring. And the same thing if we go horizontally or diagonally. As long as we cross that curve, we have a phase change. Between a solid and liquid, which is going to be line BD, so this line keeps on going and going and going, we end up with the melting curve. So line BD is the melting curve. So depending on what we're doing, if pressure is held constant and we increase the temperature and we go from a solid to a liquid, here we have melting. If we go from a liquid to a solid, we have freezing. Then if you notice, we have another line segment, BC. And the arrow doesn't go on here. So this stops up here and we end up with liquid and a gas kind of being one thing. And we'll talk about that here in a second. But segment BC is called the boiling curve. And it demarcates the interplay of pressure and temperature with changing between a liquid and a gas. So if we're going in this direction, we are boiling, liquid to a gas. And if we go from a gas to a liquid, we are condensing. But we also have 2 points that we have to describe, point B and point C. Point B is where all 3 line segments or lines intersect. So at this intersection point is the intersection between solid, liquid, and gas. So this is called the triple point. And if we extrapolate back and get the temperature and pressure of this point, which would be the XY coordinates of this point, it gives us the temperature and pressure at which all 3 phases of matter are in equilibrium with one another. And I will put up a video from YouTube in Schoology that you can watch that shows for a substance, you have to have very good conditions in order to find a triple point. And you can see that it changes back and forth from a gas to a solid to a liquid all around the same time. It's pretty cool. Point C up here is called the critical point. This is the temperature and pressure at which a gas can no longer condense. So the gas has so much energy, even though the pressure is really, really high and it's forcing it together, that it cannot liquefy anymore. And a supercritical fluid is what we call this fluid-like state where we have a mix of properties. So a supercritical fluid is a fluid-like state above the critical point. Now, the last thing that we'll talk about is the water diagram is a little bit different. And water, we know that pressure and temperature between solid and liquid, water is unique because water is less dense as a solid. Most things are more dense as a solid, but water is different, which allows ice to float. Line BD has a negative slope for water. So it's not a positive slope. It will actually be not positive like this one. It would be this direction. So water has a very telling sign in its phase diagram. So based on this, if I gave you 2 points on the diagram and said, what happens if you're moving from this point to this point, you could say that the substance melts. Or I ask you to identify the triple point. You could say point B in this diagram. So you should work on the phase diagram worksheet that is posted in Schoology.